So this is my task 7.1. So the original thing we had to do was create a abstract transaction class. I've done that here. Um, Basically, it's really tidied up the code because we've taken certain things that are all common in these other classes and put them here. Also added some extra functionality. I've made it so that all these classes are now derived from the transaction class, and they'll work well with it. There's no conflictions. I've got their constructor calling the base constructor as well. Yeah, so basically, next step of the program was, yeah, they'll work with it. Yeah. Oh yeah, so I call the base class execute method first in every execute of the child, like the instructions ask me to. Got that. Also followed that. So bank execute transaction, rollback transaction. Yep. Okay, so also got the print transaction history, just iterates through. So if we go to the bank, print transaction history, so just for each one iterate through, and it also provides like the number of the transaction there. What else do we have? Yeah, I've added that menu option. That's in the account. Print transaction history. So print transaction history, it does that, but it also has the rollback option at the end of it, which is what we had to implement at the end. So basically, when we choose to print transaction, print transaction history, we basically get the option to do a rollback of whichever transaction we pick based on the index. And the place that I've got that is do print history and do rollback. So yeah, basically, I had to have a way of accessing at least an element of the list. Not 100% sure how to best handle private lists, but I've created kind of like a property for the list where it will return an element based on the given index. And you can see that in where did I put that? Oh, yep, just here. So get transaction based on index. Yep, so I had to use that in order to implement the do rollback function. So I'll show how it all works now. So let's create an account. We'll call it Ash. Give me $100. We will withdraw from the account. Ash 10. Deposit Ash 50. Now we'll bring up our transaction history. So we have 2. We'll change the deposit. So that's been reversed. Now let's do our print. We should see our balance is back to where we should expect it to be. I'll just show how transfer works. So 5, add new account, on $100. Okay, so do a transfer from Ash to Mon, $10. So we'll check that. 80. Mon's got 110 as you'd expect. Okay, now we'll go to the transaction history again. So what was that last one? So we want to change his transaction number to okay, now let's check our accounts again. Got 90. Got 100 as you'd expect. Okay, yeah, so that's pretty much it for this one. Oh, I should probably discuss the following. Explain how inheritance and polymorphism were used in the solution. Well, inheritance allowed us to reuse code for our different transaction classes based on the base transaction class. We were able to easily reuse things like the reversed and executed properties. We were able to reuse some code from the from execute. Transaction was common to like the amount. Everyone needed an amount. It also inheritance and polymorphism are sort of like kind of interlinked because based on the fact that we have all of these inherited from this, we can just simply maintain a list of transaction in the bank. So polymorphism, basically we're able to just iterate through this list and call the any function that's common to transaction. So that's an example of how they work and how they're sort of combined together. I think this is referring to the execute method. So basically the reason it can do that is because we've overridden. So I think it's referring to this execute transaction. So the reason it's able to do it is because execute is a virtual method in the base class. So basically if we call execute from any child class, it will call the changed overridden variation of execute. The unique thing about this is in our execute we're also calling the original from base class. So that's how it can work on any transaction. What changes would you need to make to the bank to include a new transaction class? Let's see. No changes to the bank class. They're pretty much separate from each other. Bank class only needs something of child transaction. So as long as our transaction class is still derived from transaction, we wouldn't have to change the bank class. Ability to reuse code. It unlocks the ability to use polymorphism. Yeah. What advantages do we get of polymorphism? Big advantage of polymorphism is the ability to upcast and downcast. So basically we can store everything as a collection of type transaction and then run through every element of that, and the code pretty much knows based on overridden methods and such, what variant to call. That's a huge benefit of polymorphism. So now bank class, we can make lots of different types of transactions as long as they're derived from this transaction class. The bank class doesn't really need to know about their existence or anything. Just it can just call them from this transaction list. Yeah, so that's pretty much the end of this one.